Alrighty, we are live. So, before we get going into Desmos, and we play Desmos, as you say, what is slope? Rise over the run, we say. What else you got for me? What else is slope? Olivia. Ooh, y equals mx plus b is not the slope, but it does have slope in it. And that's it, right? But I'll take that. So there's the slope, right? What else? Yeah, what? Vertical change. Horizontal change. We're just going to leave it like that. All right. Yeah. Yes, you may. What else? What'd you say? Not really, but I know what you mean. Something with the y's, something with the x's, right? Let's learn some Greek letters today. That's a Greek letter. Delta is what we call that, lowercase. Delta means change in math. So when we say change, vertical change, we can say delta y, and we can say delta x. Vertical change because of y. X, horizontal. What else you got for me? Anything else? If I give you a line, like this, and I give you 2 points, Skylar, join us back up here. It's all good. Here's our line. There are the 2 points. How do I find the slope of that line? How would you go about it? Shion.
You start on that dot.
Okay. And then what?
And you go up and go,
Yep, to there.
and then you go over to the right.
Mm-hmm. So we went to the right 2, so that's positive. And we went up how many? Looks like 5. So our slope is 5 over 2, right? So what you're saying here is vertical change, horizontal change, right? That's what we talked about. Let's find the coordinates here. Looks like this guy down here is 2, 1. And this guy right here looks like 1, 2, 3, 4, 6. What else is slope? How can we calculate slope? We can subtract, can't we? What are we subtracting? The y's, right? We're subtracting the y's and we're subtracting the x's. In other words, we are finding the distance, the change between the x's and the change between the y's. How much did they change? Look. These 2 numbers right here, going from 2 to 4, how much did they change? 2. They changed by 2. So horizontally, because those are the x values, we changed by 2. How'd you figure that out? 4 minus 2, right? What was the change between 6 and 1? Yeah. How much did we change between 6 and 1? 5. So subtraction is distance, but it is also change. How much we have changed in the horizontal direction. That's what that is, right? So you can easily look at these. Do you need to memorize this formula? No. Of course that's what it is. Slope is the change in the y, change in the x, right? Vertical change over horizontal change. The rise over the run. You know what it means. I can give you any 2 points and you can find the slope very easily. Here it is. Here's some points. You're going to find the slope. Give me a number. Has to be an integer. Ethan. Integer, go. CJ, integer, go. Caden, integer. All right, so you gave me all positive integers. Fair enough. Those are all actually natural numbers. So what is the slope going to be here between those 2 points? It's the change in y over the change in x. So how much did the y's change? Here are our y values. How much did they change? By 5. Now, if we started at 8 and we went down to 3, we subtracted 5. Do you want to start at 3 or start at 8? Start at 8, so we subtracted. Now, if we started at 8, we have to start at 5 here. So how much did the x's change? We went from 5 to 7, so we went up 2. So there's our slope. It's the change, right? That's all it is. How much did they change? Now, depending where you start, the change is going to be different. Same thing with our last diagram, right? If I started here, I would have gone left 2 and down 5, right? Instead of up 2 and over 5. Or I'm sorry, up 5 and over 2. Right? So where you start matters. Let's try it again. Give me some more integers. Negative 12, 4, 6, negative 2. All right, let's find the slope. All right, so the change in y, I always start with the second one. So negative 2 going to 4. How much did we change? By 6, right? Negative 2, you add 2 to get to 0 and 4 more to get to 4. Or 4 more to get to 6, I should say. So we get 6 in total. The x values, we started at 6 and we're ending up at negative 12. What do we do? Well, we subtract 6 to get to 0. And then how much more to get to negative 12? So we subtract 6 and then subtract 12. That's the same as just subtracting 18. Is there a way to simplify the slope? Question. Whoops. Ah. True or false?
Same thing, yes.
Same thing, which is also the same thing as this. True. All are the same. All are the same. Because negative 1 divided by 3 is going to be a negative number, a third, right? 1 divided by negative 3 is going to be a negative number, a third. Do we feel comfortable with slope and slope formula? Wonderful, I got something new to show you. Here's slope formula, you just said it, right? It's the change in y over the change in x, right? Which we know just means this, right? So we know that slope equals y2 minus y1 over x2 minus x1. And we know for Nevaeh, if this was a 2, how would I get rid of the divides by 2? Multiply both sides by 2, right? So instead of 2, we have x2 minus x1, so we're going to multiply both sides by x2 minus x1. We get m times the quantity of x2 minus x1, right? There's 2 terms there, so we have to wrap it in parentheses when we multiply. And that gets rid of it in the bottom, so now we're here. Now, we just took the slope formula and changed it in this. We call this point slope form, because you plug in 2 points in your slope and it gets you the equation type of deal, right? I don't like thinking of it as a totally different thing, because really it's just this guy just moved around, right? It's the same dumb crap, just rearranged. Should every time we move something, should it change it? I don't think so, right? It's just a different way of looking at it. What this allows us to do is allows us to plug in some coordinates and find out what our slope is, right? That's what this is. But it also allows us to only plug in some coordinates, leave the other y and x alone, and plug in our slope and get an equation. So here's what I mean by this. What's the equation of line? Give me a slope. Yeah, give me a random slope. 7 over 2. Give me a coordinate that you want that line to go through. 4, negative 2. Okay, so we want a line that has that slope. Is that a very steep slope or not a very steep slope? It's all right, right? It's 7 over 2. Up 7 over 2 is relatively steep, right? 4, negative 2 is the point it's going to go through. So let's find the equation of that line using this. I'm going to call that x1, y1. And there's our slope. So our slope is 7/2. That's what I'm plugging in there. Do I know what my x2 is? No, I'm only given 1 point, right? So I'm going to leave that alone. I'm going to call it regular x. What's my x1? 4. We don't know y2, so I'm just going to call it y. What's our y1? -2. So when I plug this stuff in, check out what happens. Let's simplify this a little bit. It's got a lot of signs we can distribute, right? I'm going to distribute the 7/2. So we get 7/2 x. Here, times 7 and divide by 2. Which would you rather do first? Divide by 2. What's -4 divided by 2? 2. -2, right? Now times it by 7. -14. Very good. That's all good, right? I usually just write down the sign. I've got a positive times a negative. Write down the sign and then forget about it, right? We have y minus a -2. Really, it's -1 times a -2. Whenever we times a negative by a negative, we get a positive because timesing by a negative always changes the sign. So see how it's already negative? If we negate it, it becomes positive. Cool. I'm going to subtract the 2. We get this. And I'm going to flip it around now. Symmetric property. That is the equation of the line. Didn't we say we wanted a line that goes through, it has a slope of 7/2?
Yeah.
Did it. There's the slope. Y equals mx plus b, right? And we wanted it to go through 4, -2. Well, in order for it to do that, we had to slide our line down 16. Right? Normally, when we have a line with some random slope, it goes through the origin unless otherwise specified, right? Any slope that you give me is not going to change that. Well, what changes is that value on the end there, that b value, that -16 that we're seeing on there, which now means it's going to hit here at -16. Same line, just moved down. We learned that yesterday in decimals, right? So if it says, give me a line of 7/2, we know what that is, right? Really what we're trying to figure out is, what does this have to be so it goes through that point, right? That's the magic there. So this thing right here is not something for you to memorize. All it is this. And you know what that means. It's this. Why is it that? Change in y. How much we changed vertically, right? So if I'm at 8 and I went down to 2, how much did I change? I went down 6, right? 8 to 2, down 6, right? 8 minus 2 is 6. If I'm doing x value, I'm over at 10 and I move to 12. How much did I change? By 2. I went up 2. 12 minus 10 is 2. That's all this means. Change in y, change in x. Change vertically, change horizontally. We can look at coordinates and figure that out very easily, right? Again, I'm at 8. I went down to 3. I changed by -5. I'm at 5. I went down to 7. I changed by, or I went up to 7. I changed by 2. There's the slope, right? So we know what slope formula is, not because we have it memorized, but because we understand what it means, right? Of course the slope is rise over the run. How much we change vertically, how much we change horizontally. And from there, we can get this. Just move it over, right? Same dumb crap. What if we didn't move it over? What if instead we were lazy and we're like, look, I don't want to move all that over first. I don't have to think of another formula. Slope is rise over the run, which we know is the change in y over the change in x, which we know just means the difference between them, right? How much distance has changed. Distance is subtraction. So we know that this is true. All right. Give me a slope.
5/2.
How about -5 over 2?
Alright, that's cool.
Give me a coordinate you want our line to go through. 4, 1. Okay. Let's plug it into this. Last time we moved this over first and then plugged it in, right? It's the same equation. Should work out just fine. So here's where our slope goes, -5/2. And that's going to equal all this crap. Well, I don't know what y2 is. Right? And I don't know what x2 is. So I'm just calling y and x. What's my y1?
I mean,
What's my y1? Put your Chromebook away. Isaiah, put your Chromebook away. You're staring into that and staring up here. Okay? So it's 1. What's our x1? Whenever I plug stuff in, I wrap it in parentheses, right? We talked about that, practicing safe x. So now let's simplify this. We have negative 5 halves equals y minus 1, x minus 4. Where have you been all year, dude? I've been making jokes like that constantly.
what'd you say?
Practice safe x.
Oh,
Whenever
yeah.
you plug something in, like for x, you want to make sure that you wrap it in parentheses.
Wrap it up. Got it. I don't pay attention though.
I know, you really should. It's funny. All right, so now we're here. Now I want to get y on its own, right? Because our equation that we're looking for is a y equals mx plus b, right? Y equals mx plus b, so y is on its own. So how do I get y on its own? Well, what do I do to the bottom? I get rid of the entire bottom. How do I get rid of that? Multiply by x minus 4 to both sides. I get this. Do you see where you end up?
Yes.
Ta-da. It's a natural consequence, right? We get negative 5 halves x when we distribute. Negative and negative makes a what? When we multiply. A positive. So now we can forget about the signs. This is 4 divided by 2, which is 2 times 5, which is 10. Add 1. So y equals negative 5 halves x plus 11. That's the equation we're looking for. A line that goes through 4, 1 and hits, goes at an angle of negative 5 halves, right? Has a slope of negative 5 halves. Yes?
So this will be negative 5 halves.
There it is.
That looks like it's free.
It does.
There you go.
Right?
Is that thing up?
Always. It can hear you.
Ah.
Sausage, right? All right.
That was a good one.
Here it is.
It's, I mean, if you want sausage.
Here it is.
What, actually, Desmond style?
Yeah. We're playing this, as you say.
Yes.
And our NQJZ, Z, as you say, Z. Student.desmos.com. Type that code in, make your name. Yeah, over 24 hours. Well, not over 24 hours, actually. Yeah, 24 hours. 24 hours to figure out your name. We'll see you guys come up with some. Baker, if you are at home watching, first of all, like, subscribe, and leave a comment. And also, you may enter this as well. And you throw this up on the interwebs. Whoa. So now you can see two.
Well, we didn't actually watch.
It could be. We don't know.
What do you mean this one if he's not? Well, he'd be either not that big if he's not watching.
He's gonna watch it eventually, right? Alright, let's see what names we got. Crippled. Could be any of you. Seems like the most dangerous sport in the world is volleyball. Danny.
That's me.
Ethan. Gur. Is that a reference to a TV show?
No.
No? Okay.
I know what you're talking about.
Josh who lost E2K19. That's long. Mama. Mentally crippled with a K. Nevaeus Roby. Right? Nick. Of course. And Peter Ennis. Got it. I think you should have gone more subtle. I really think you should have gone more subtle. It would have been funnier. But I did it for you. Peter Ennis.
I'm just being Josh.
All right.
Hey,
Everybody in?
no. Can you get rid of Nick?
No, I can't, and I don't care. Are we good?
Chose Isaiah?
Are we good?
Yeah.
QJZ.
And here we are.
I'm in.
We have Radio Gaga, which is a song sung by Queen. Right? Sally and Y in all caps. All right, so we're on slide number 1. We got Broski in there as well. All right, so a line through a point. It says below, write an equation for a line that passes through 2, 4. So any line that goes through 2, 4, right? There's how many different lines go through one point?
A lot.
A lot, right? Here's a point. Here's a line that goes through it. So it says me. Here's another line that goes through it.
Got it.
Here's another line that goes through it. You have lots of options. Write an equation that goes through there. Let's see some of the examples. Don't move on. Stay with me. We got people on slide 3. Go back.
What? I was on slide 1.
Does it go from 2, 4, correct, Ed?
So we have y equals 2x goes through it.
Y equals
So,
X plus 2.
I'm mentally okay.
I did mine.
Still does not go through 2, 4.
Boom.
Looks like everybody did the same one. Can you make any others? Come on, be creative. Oh, Sally's got some options.
I made one.
Y equals 4, x equals 2.
I don't know.
So check it out. Sally said, look, I want it to go through 2 on the x-axis, or in the x direction, right? There's 2, 2 to the right. So what if I made a line that goes perfectly just through 2 to the right? Well, what line would that be? X equals 2, right? Here's where x is 2. So let me write a line where x equals 2. That makes sense. Again, if I change that to x equals 3, see how it goes through 3 now? Well, if I want it to go through 2 on the x-axis, well, here we go. Ta-da! And of course, y equals 4 is also a valid solution, right? Because y equals 4 in this coordinate. Y equals 4 is the line where all of the coordinates where y is 4 show up. So if this one has a y value of 4, it'll show up on the line y equals 4. Right here. Nice job. Any other creative ones? We got people playing around with a green line, trying to find another interesting. Mama! Whew! Got a lot of ones here. Working on that red though. Red doesn't quite go through it.
Yeah, I know.
Neither does blue.
Yeah, don't mind that one either.
Fair enough. Let's look at number 2. Everybody on slide 2 now. Moving on. A line through a point with a negative slope.
Done.
So a negative slope. So 2x didn't work. It doesn't work this time, right? Because that's a positive slope. We need a negative slope. Let's see what you got.
Negative 2x.
Broski,
Whoa.
negative slope. Checks out. Very simple slope, -1.
Exactly. Negative X.
Think about what this means. The 6 here. Eyes up here. The 6 here means we're starting at 6, basically, right? On the y-axis. It's up here. And then we're going to subtract
What did I do?
1 each time. Right? That's what that slope means, down 1 over 1. So if we start at 6, and we subtract 1, we're now at 5, right? If we subtract 1 again, we're now at 4 on the y-axis. Do you see how that'll definitely go through something with a 4 in it? Because we'll be able to subtract 1 twice and get there. What other interesting ones we have?
Number 4.
Josh has an interesting one. Negative 8x plus 20 goes through it. So we're starting at plus 20. Look at the y-intercept. It's all the way at 20. We subtract 8 once. We're down to 12. Subtract 8 again. We're at 4. Moving on to number 3. Move back to number 3.
Yeah, look.
Y.
Yeah, Y. Who's Y? Why are you Y? It's Troy. You're too slow. Yes, just because Troy.
Question 1 says, make a line through a point. Question 2 says, a line through a point with negative slope. Is it possible she could have had the same answer for 1 and 2? That's question 3. Yeah, right? She could have had the same, actually. Right? Because her first answer could have had the negative slope too.
Yes.
Right? First answer just said, do it. Second one said, hey, do it with a negative slope. Well, what if she already did it with a negative slope? Right? So yeah, she could have. 4, a line with a slope and a y-intercept. So what they're asking you to do here is they're saying, write an equation of a line that goes with a slope of a half and a y-intercept of -2. Now, how many different lines have a y-intercept at -2 and a slope of a half? Just one, right? Only one. So everybody should have the same answer for this one. Y equals mx plus b. Type in your slope. Type in your y-intercept. Right?
I think I did it.
What was your answer?
What do you mean?
What do you mean? What do you mean? What do I mean? What
I
was your
got
answer?
one. I got like, what do you mean?
Well, you said you did it. You did what? Right. And so what did you write?
You gotta write something about it? Yeah.
What equation did you write?
Y equals a half x minus 2.
Yeah. That's what I was asking. It's like mine.
Yeah.
Check out 5. It says another line with a slope and a y-intercept below. Write an equation with a y-intercept of 2 and a slope of a half. So before it was y-intercept at minus 2, slope of a half. This one's saying y-intercept at 2, slope of a half. How do they differ?
I think I did.
That's the next slide, number 6. How are those two graphs different? After you do it, share with the class what you said.
The y-intercept was a negative before.
You passed?
Sing it. Pass his name with
Like laminated? Yeah, no, I want to. I just do it, seriously. Make them look official. Do it. I just never get up to the laminator.
Do you play guitar?
Do I?
Yeah.
I do, yeah, but that's not my pick. It was actually Jerica's. I got to get it back to her. Forgetting how to spell Tucker.
You just put an F there.
Did we joke about Tucker with an F, like literally writing all of that out? G1.
Yeah. Got Will.
All right, they know different. Broski, they better be. One has a positive 2 for its y-intercept, the other has a negative 2 for its y-intercept. So they're going to be the same line, it's just one's going to be higher up, one's going to be lower, right? The positive 2 is going to be higher up, the minus 2 for the y-intercept is going to be lower down. We've got a lot more to go.
There's 17.
I want you guys to complete this for homework.
Chrysler.
What? You want
Bet.
to create a new line?
I got you.
You can work together. I would encourage you to.
Work together.
If you work together, I would encourage you to explain it, because guess what? This stuff's going to pop up on Friday. Not in Desmos form, but on your quiz.
Oh.
Line?
We got one more day of learning stuff tomorrow, and then we'll do a review on Thursday.
Y equals
We'll have the stuff from last week and this week all up together on the quiz.
2.
Yeah, I took it off you.
Oh, it's gone. Problem with
Slash
line.
stretching. He had some PTSD right there.
Of what? Cinderella?
If you have questions while you're doing this, ask them. Go at your own pace now.
What another good name be? Anna L.
That is a good one. Yep, I got it. It wasn't so obtuse that I wasn't able to figure it out. Pretty straightforward.
You never know what to do. Oh yeah, my lesson.
And that homework.
Oh, you have like 6 and 7.
Oh, sweet. Freshman Academy.
Yeah, freshman academy.
I hated that. 2 days, Thursday.
I had Stevenson and oh man.
Oh, you
I
must
had
have fun.
Stevenson.
I bet it's so fun.
I had one.
We're here? We're queer. Get used to it, Tucker, because you're not a steer. Yeah.
Have you eaten this boat building, or do you have like future dreams?
I have a better choice.
Oh, good.
Who does? Oh, you always listen. Catch you later, big guy. I think I'll start the PP Tuesday? Alright. Oh, look at that. That's today. Oh, you sucker.
Tucker. Make me mad, Tucker. You make me mad.
Good.
You disappointed too.
Good.
Are you all salty?